Good morning. Now, today we will learn about microcontrollers. Now, this is actually the unit 3 of your paper microelectronics and semiconductor devices. That is the name of the paper. So, in that paper, that is microelectronics and semiconductor devices, I will be teaching you the third unit, which is about microcontrollers. So, in that, the first topic in that syllabus is Introduction to Microcontrollers and Embedded Systems. So today we will learn about microcontrollers. I mean, what are microcontrollers? What is the definition for a microcontroller? What are the various types of microcontrollers available in the market, and so on. Okay. So now let us start. Microcontroller is nothing but a true computer on a chip. It incorporates, that is, it has got a CPU, then central processing unit, that is, then ALU, arithmetic logic unit, then PC, that is program counter, then SP, stack pointer, then registers. It also has got a ROM, read-only memory, then random access memory RAM, then parallel and serial input output counters, and clock circuit. Now it is a general purpose device, and it actually fetches the data, perform the calculations on that data, and control it depending upon the environmental um, uh, conditions, that is, the various conditions based on that. That is what the meaning of environment there. That is, it fetches the data, perform the necessary calculations on that data depending upon the environment, that is, depending upon the conditions applicable on that data. Now, the prime use of microcontroller is mainly to control the operation of a machine using a fixed program which is stored in the ROM, and that does not change over lifetime of the system. Now, it is of single design which can be used for as many as applications as possible, and it can work on both single and double byte instructions which are used to move the code and data from internal memory to arithmetic logic unit. Now, many instructions are coupled with the pins on the IC package, and one of the most important point is that all these pins of the microcontroller are programmable. That is, it can be programmed according to the wishes of the programmer. That is, it is capable of having different functions depending upon the wishes of the programmer. Now, this is actually the block diagram of a microcontroller. From here you can see that it has got an ALU, then accumulator, register set, internal RAM, internal ROM, stack pointer, program counter, clock circuit, interrupt circuits, input output port, timer, counter, etc. So these two paragraphs are very important because it includes all those points that you should know about a microcontroller. So study these two paragraphs very well, as well as the block diagram of the microcontroller. Okay. Now let us see a brief survey or about, there are various types of microcontrollers, that is 4-bit, 8-bit, then 16-bit, 32-bit, etc. So here nothing much to explain. It's enough that you read through all these paragraphs. So in order to minimize the pin count and package size, it is necessary that the basic data word bit count must be minimum. So for that, the first microcontroller that was introduced in the market was that of 4-bit, and it is the most popular microcontroller, and some of the widely used 4-bit microcontrollers are presented here. There is no need of by hearting all this one. You can study just one or two. You can quote it as an example. So just write a brief paragraph about 4-bit microcontrollers and just give an example for that. Now, these 4-bit microcontrollers are mainly used in large volumes as true one-chip micro computers, expanding for expanding external memory, and it is mainly used for typical the typical applications consist of appliances and toys. Okay, so these are the uses of a 4-bit microcontroller. Next is about 8-bit microcontrollers. It actually represents a transition between 4-bit microcontrollers, and it is of high performance and the high performance. Okay, so that is 8-bit microcontrollers actually comes in between 4-bit and 16 and 32-bit microcontrollers. And these 8-bit microcontrollers are used for performing small computing tasks. It is underlined here. It is used for performing small computing tasks. Then it is capable of 256 decimal values. Then 1 byte word is adequate for it to perform the control and monitoring applications. Then ASCII data is stored in byte size here. Then can also be used for data communications, and most of the logic functions in this 8-bit microcontrollers are arranged in an 8-bit configuration, which is very easy to interface with the 8-bit data buses. Then another point is that uh, some of the application sophistication can also range from simple control operations to higher control operations and data collection. For these reasons, microcontrollers manufacturers have established extensive families of 8-bit microcontroller models. Then next paragraph is about the ROM and RAM EEPROM features of this 8-bit microcontrollers. Now these microcontrollers can be used to solve most of the problems. Then the ROM-less or EEPROM versions can be used uh, in many applications. Then the designer can make this EEPROM design sufficiently general. That is, he can make that design of EEPROM very general so that one configuration can be used many times. That is what the meaning of generalizing the EEPROM design. That is, the EEPROM design of 8-bit microcontrollers can be made general. That is, the same configuration can be used many times. And then other features include fewer shrinkage of the package, and few the cost is also less. Then analog to digital and digital to analog converters are also incorporated in it. Then this next is about some of the examples for 8-bit microcontrollers. Just study one or two from here. Then 16-bit 16-bit 8-bit microcontrollers can be used in a variety of applications that involve limited calculations. That we already said, it is used for small computational tasks, or for calculations that require very little steps to solve. That is, for simple control strategies, 8-bit microcontrollers are used. Okay. Now, as the requirement for faster response and more sophisticated calculations grows, that is, if you want to need uh, a faster response, and as well as if the calculations involved is high, then we cannot use this 8-bit microcontrollers. So the only solution is to increase the clock speed, and the other is to increase the size of the data word, but you cannot use this 8-bit microcontroller. So in order to solve this problem, manufacturers and have introduced the 16-bit microcontrollers to the market, and they can solve very high speed control problems. Okay, now these microcontrollers are used in order to control the robot arms, as well as in digital signal processing DSP applications and all. These 16-bit microcontrollers are used because it requires faster response and high-speed calculations or complicated calculations. It is also used in data communication systems like pulse width modulation systems, etc. Now then the 16-bit microcontrollers have been designed to take advantage of high-level programming languages. Okay, now these are some of the examples for 16-bit microcontrollers. Just study one or two. I think one is enough. Now the last one is the 32-bit microcontrollers. Now 32-bit designs target, they are mainly used in robotics, then highly intelligent instrumentation, then avionics, image processing, telecommunication, automobiles and other environments that feature application programs running under an operating system The line between microcomputers and microcontrollers becomes very fine here. Now it also has got RAM, ROM, timer, serial ports, then high-speed computation features, etc. These are some of the hardware and software features of 32-bit microcontrollers that you have to study. Then all the functions needed for input output data communications, timing and counting are done by adding other specialized chips in order to, that is, in order to perform such communications or to perform such functions, we have to add specialized chips to these 32-bit microcontrollers. Now, this manufacturer has dubbed all of its microcontrollers embedded controllers, a term that seems to describe the function of 32-bit microcontrollers very well. So, that's all about microcontrollers. So, as I already said, study those first two slides that deals with microcontrollers very well along with the block diagram, and then write about these types of microcontrollers available in market starting from 4-bit, 8-bit, 16-bit, 32-bit. Just write up a paragraph about each of these microcontrollers, mention one or two of its uses, and just give an example. Okay, that is enough. Then so that's all about microcontrollers, a brief introduction about what is a microcontroller, what are the types available, the block diagram. Okay, so just read through these paragraphs. Then in the next class we will learn about embedded system, that is introduction to embedded system. Embedded system is nothing but something that has got a microcontroller incorporated in it. For example, washing machine that you use, it is actually an embedded system because it has got a programmable microcontroller incorporated in it. So washing machine that you use in one sense is an embedded system. So we will learn more about embedded systems, I mean an introduction, in the next class. So for the time being, this is enough for today. Okay, thank you.